Hello, my dear children. Before going to start the sums in exercise 3.3, you should learn well the definition of transpose of a matrix, properties of transpose of the matrices, and the definition of symmetric and skew symmetric matrices well. Okay, my dear children. Right. Now let us start the exercise 3.3 sums. Right. Now see the question number 1. Find the transpose of each of the following matrices. We have to find the transpose of the given matrices. See here, first question, matrix 5 1 by 2 minus 1. Only one column matrix is given. Now let us consider this matrix is A. A is equal to matrix 5 1 by 2 minus 1. What is the order of this matrix? 3 by 1, because 3 rows and 1 column is there. So this is a 3 by 1. Now we have to find transpose of this matrix. What is meant by transpose of a matrix? How do you find transpose of a matrix? By interchanging the rows and columns. So here only one column is there. We write this row column as one row. So only one row. 5 1 by 2 minus 1. So this is a transpose of the given matrix. It is denoted by TR of A or A transpose or A dash. All these three notations denote the same. Understood, my dear children? Right. Now come to the second part of the question. Matrix 1 minus 1 2 3. This is a given matrix. We have to find the transpose of this matrix. Let us consider the given matrix is B. So B is equal to matrix 1 minus 1 2 3. What is the order of this matrix? 2 by 2. Then we have to find the transpose of this matrix. Then transpose of the matrix. Transpose by matrix B is equal to TR of B, that is equal to B transpose, that is equal to B dash. All these three notations denote the same transpose of the matrix B, that is equal to matrix 1 2 minus 1 3. By interchanging the rows and columns we get this matrix. This order of this matrix also 2 by 2. Understood this step, my dear children? Right. Now come to the third part of the question. Matrix minus 4 5 6 1 2 0 1 3 1. This is a given matrix. We have to find the transpose of this matrix. Let us consider the given matrix is C is equal to matrix minus 4 5 6 1 2 0 1 3 1. Now we have to find the transpose of the matrix C. It is denoted by TR of C, that is equal to C transpose, that is equal to C dash. Remember these points, my dear children. Right. That is equal to, this is the first row, minus 4 5 6. We write this first row as first column, minus 4 5 6. Now come to the second row, 1 2 0. We write this second row as a second column, 1 2 0. Now come to the third row, 1 3 1. We write this third row as a third column. Understood, my dear children? Right. First, let us write the given data. What is given here? A is equal to matrix minus 1, 2, 3, 5, 7, 9, minus 2, 1, 1. And B is equal to matrix minus 4, 1, minus 5, 1, 2, 0, 1, 3, 1. Okay, my dear children, just we wrote the given data here. Now come to the first part of the question. First we find A plus B, because we have to find A plus B whole transpose. Without finding this one, we can't find A plus B whole transpose. That is why we are finding A plus B. Means we have to add matrix A and matrix B. So first I wrote here matrix A plus here I wrote here matrix B. Understood this step, my dear children? Right. Now I am adding the corresponding elements, because we are adding these two matrices, means we have to add the corresponding elements. So minus 1 plus minus 4 is equal to minus 5. 2 plus 1 3. 3 plus minus 5 minus 2. 5 plus 1 6. 7 plus 2, 9. 9 plus 0, 9. Understood these elements, my dear children? Right. Minus 2 plus 1, minus 1. 1 plus 3, 4. 1 plus 1, 2. Understood these elements, my dear children? Right. We found here a plus b. Now we find a plus b whole transpose. Means we had to interchange the rows and columns. Here first row elements are minus 5, 3, minus 2. We write this first row as first column. Minus 5, 3, minus 2. Understood, my dear children? Now come to the second row. What are the elements in the second row? 6, 9, 9. We write this second row as second column. So I wrote here as a second column 6, 9, 9. Okay, my dear children? Right. Now come to the third row. We write this third row as a third column. Minus 1, 4, 2. Understood this step, my dear children? Right. We got here A plus B whole transpose. Now we find A transpose. A transpose means by interchanging the rows and columns in the matrix A, we get A transpose. So minus 1, 2, 3. So I am writing here as a first column minus 1, 2, 3. Second row 5, 7, 9. We write it as second column 5, 7, 9. And third row is minus 2, 1, 1. We write this third row as third column minus 2, 1, 1. Then we got here A transpose. Similarly, we find B transpose. From the matrix B, we find its transpose by interchanging the rows and columns. What is the first row? Minus 4, 1, minus 5. We write this first row as first column. Minus 4, 1, minus 5. What is the second row? 1, 2, 0. We write as second column. 1, 2, 0. What is the third row? 1, 3, 1. We write this third row as third column. 1, 3, 1. Understood, my dear children? Right. Now we find A transpose plus B transpose. Means we have to add these two matrices. So I wrote here A transpose matrix plus here we wrote B transpose matrix. Understood this step, my dear children? Right. By adding the corresponding elements, we get here minus 5, 6, minus 1, 3, 9, 4, minus 2, 9, 2. Okay, my dear children? Right. By comparing A plus B whole transpose and A transpose plus B transpose, they are equal. Okay, my dear children? This is the first part of the question we have proved here. Now come to the next part of the question. First we have to find A minus B because we have to find A minus B whole transpose. Without finding A minus B, we can't find A minus B whole transpose. So first we are finding A minus B. So first I wrote here matrix A minus here I wrote matrix B. Okay, my dear children? Right. Now I am writing the elements. Minus 1, minus of minus 4 plus 4. 2 minus 1. 3 minus of minus 5 plus 5. Understood these elements, my dear children? Right. Second row. 5 minus 1. 7 minus 2. 9 minus 0. Understood these second row elements, my dear children? Right. Now third row. Minus 2 minus 1. 1 minus 3. 1 minus 1. Understood these elements in the third row, my dear children? Right. Now we simplify these numbers. Minus 1 plus 4, 3. 2 minus 1, 1. 3 plus 5, 8. 5 minus 1, 4. 7 minus 2, 5. 9 minus 0, 9. Minus 2 minus 1, minus 3. 1 minus 3, minus 2. 1 minus 1, 0. We got here A minus B. Now we find its transpose. So A minus B whole transpose is equal to, how do you get transpose of a matrix? Just by interchanging rows and columns. So this is the first row 3, 1, 8. We write this first row as first column 3, 1, 8. Understood, my dear children? Now come to the second row 4, 5, 9. We write this second row as a second column 4, 5, 9. Now come to the third row minus 3, minus 2, 0. we write this third row as third column, minus 3, minus 2, 0. Understood this step, my dear children? Right. Now we find A transpose minus B transpose. Here I am writing, we have already found A transpose, minus 1, 5, minus 2, 2, 7, 1, 3, 9, 1. Okay, my dear children, minus B transpose. Here minus 4, 1, 1, 2, 1, 2, 3, minus 5, 0, 1. Okay, my dear children, I am writing here transpose of the matrix A and matrix B directly. Now we are subtracting minus 1 minus of minus 4 plus 4, 5 minus 1, minus 2 minus 1. These are the elements in the first row. Understood, my dear children? Right. Next, second row elements. 2 minus 1, 7 minus 2, 1 minus 3. Understood the elements in the second row, my dear children? Right. Now come to the third row. 3 minus of minus 5 plus 5. 9 minus 0. 1 minus 1. Understood the elements in the third row, my dear children? Right. Then we get matrix 3, 4, minus 3, 1, 5, minus 2, 8, 9, 0. Okay, my dear children, this is A transpose minus B transpose. By comparing A minus B whole transpose and A transpose minus B transpose, they are equal. So, we have proved. Understood, my dear children? Now come to the question number 5. For the matrices A and B, verify that AB whole dash is equal to B dash into A dash. We have to verify this statement. Now let us see the first part of the question. A is equal to here matrix 1 minus 4, 3. Only one column is there. 3 rows and one column. Now B matrix. Matrix B is equal to matrix minus 1, 2, 3. Here only one row, 3 columns. Okay, my dear children? Right. Now we have to verify this statement. First of all, we write the given data. What is given here? A matrix. We are writing A matrix here and its order is 3 by 1. 3 rows and 1 column. Similarly, B matrix. Only 1 row, 3 columns. Okay, my dear children. Now we are finding the AB. First we find AB. So, I wrote here matrix A and I wrote here matrix B. You know how to multiply two matrices. In the first matrix we take only rows. In the second matrix we take only columns. First row, here only one element is there. So 1 into minus 1. This is over with the first column elements. Next to first row into second column elements. So 1 into 2. Similarly 1 into 3 third column elements. So by the first row we multiplied every column elements. Then we get first row only. Now by multiplying by second row with every column elements in the second matrix we get second row elements. So minus 4 into minus 1, minus 4 into 2, minus 4 into 3. These are the elements in the second row. Understood, my dear children? Right. Now come to the third row. Only single element, 3 only there. So 3 into minus 1 plus 3 into 2, next to 3 into 3. Understood these elements in the third row, my dear children? Right. Now we simplify these numbers. 1 into minus 1, minus 1. 1 into 2, 2. 1 into 3, 3. Minus 4 into 1, minus 1, 4. Minus 4 into 2, minus 8. Minus 4 into 3, minus 12. 3 into minus 1, minus 3. 3 into 2, 6. 3 into 3, 9. These are the elements in the matrix AB. We found here AB. Understood, my dear children? Then we get transpose of AB. Right. Now, by interchanging the rows and columns of the matrix AB, we get AB whole transpose. That is equal to minus 1, 4, minus 3, 2, minus 8, 6, 3, minus 12, 9. This is AB whole transpose. Understood this step, my dear children? Right. Now B dash is equal to matrix minus 1, 2, 3, and A dash is equal to matrix 1, minus 4, 3. Understood, my dear children? Right. Now we find B dash into A dash. That is equal to matrix minus 1, 2, 3 into A dash. Matrix 1, minus 4, 3. Here we have to multiply these two matrices. You know how to multiply two matrices. Remember that procedure. Okay, my dear children. Minus 1 into 1, minus 1 into minus 4, minus 1 into 3. These are the elements in the first row. Now if we are multiplying by second row, we get only here second row elements. So 2 into 1, 2 into minus 4, 2 into 3. Now third row, with the third row we multiply. So 3 into 1, 3 into minus 4, 3 into 3. Understood the elements in the third row, my dear children? Right. That is equal to minus 1 into 1, minus 1, minus 1 into minus 4, 4, minus 1 into 3, minus 3, 2 into 1, 2, 2 into minus 4, minus 8, 2 into 3, 6, 3 into 1, 3, 3 into minus 4, minus 12, 3 into 3, 9. We got here B transpose into A transpose. By comparing the matrices AB whole transpose and B dash A dash, both matrices are same. Therefore, AB whole transpose is equal to B transpose into A transpose, or AB whole dash is equal to B dash into A dash. Hence, the above statement is verified. Understood, my dear children? Right. Now come to the question number 6. Here the first part of the question number 6 is, if A is equal to matrix cos alpha sin alpha minus sin alpha cos alpha. This is a given matrix A. Then verify that A dash into A is equal to I. We have to verify this statement. Understood the question, my dear children? Right. So come to the solution part. First we write given data. What is given? Matrix A. So A is equal to matrix cos alpha sin alpha minus sin alpha cos alpha. Now we find A transpose or A dash. What is meant by A dash? By interchanging the rows and columns, we get a matrix A transpose. Therefore we got here cos alpha sin alpha. We are writing as column. We write this second row as a second column, minus sin alpha cos alpha. Understood this step, my dear children? Right. Now A dash into A, we have to multiply these two matrices. We found here A dash, so we write that A dash here. A already given, we write that matrix here. Understood this step, my dear children? Right. By multiplying the two matrices, we get these elements in the matrix. Cos alpha into cos alpha plus minus sin alpha into minus sin alpha. Here cos alpha into sin alpha plus minus sin alpha into cos alpha. Understood these elements in the first row, my dear children? Now come to the second row. Sin alpha into cos alpha plus cos alpha into minus sin alpha. Here sin alpha into sin alpha plus cos alpha into cos alpha. Understood the elements in the second row, my dear children? Right. You know already how to multiply two matrices. Okay, my dear children? Right. Then here we get cos square alpha plus here minus into minus plus sin square alpha. Now cos alpha into sin alpha, we can write it as sin alpha into cos alpha minus sin alpha into cos alpha. Understood the elements in the first row, my dear children? Right. Now come to the second row. Sin alpha into cos alpha plus cos alpha into minus sin alpha. What do you get? Minus sin alpha into cos alpha. Next, sin alpha into sin alpha, sin square alpha plus cos alpha into cos alpha, cos square alpha. Understood these elements in the second row, my dear children? Right. That is equal to, this value is 1. Sin square alpha plus cos square alpha is equal to 1. This is a trigonometric identity. So we wrote here 1. Here by simplifying these two terms we get 0. Here also by simplifying these two terms we get 0. Here also the same trigonometric identity 1. This is nothing but identity matrix. Understood, my dear children? Therefore, a dash into a is equal to I. Hence, the above statement is verified. Understood, my dear children? Right. Now, come to the question number 7. What is the first part of the question number 7? Show that the matrix A is equal to matrix 1 minus 1 5 minus 1 2 1 5 1 3 is a symmetric matrix. We have to prove that the given matrix A is a symmetric matrix. Do you remember the definition of a symmetric matrix? When the matrix A is said to be symmetric matrix, if A transpose is equal to A, it means we have to find first its transpose. Okay, my dear children? Right. So first we wrote here given matrix A. Then we found A transpose. By interchanging the rows and columns, we got A transpose. Now by comparing these two matrices, they are equal. Here A dash is equal to A. Therefore, by the definition of symmetric matrix, A is said to be here a symmetric matrix. Hence, the given statement is proved. Now, come to the second part of the question. Show that the matrix A is equal to matrix 0 1 minus 1 minus 1 0 1 1 minus 1 0 is a skew symmetric matrix. Understood the question, my dear children? We have to show that the given matrix is a skew symmetric matrix. Right. Here we wrote given matrix A. A is equal to matrix 0 1 minus 1 minus 1 0 1 1 minus 1 0. Okay, my dear children. Then A transpose or A dash is equal to, how do we get A transpose? By interchanging the rows and columns. So we wrote first row as first column, 0 1 minus 1. We wrote as first column, 0 1 minus 1. We wrote second row as a second column, minus 1 0 1 minus 1 0 1. Now we wrote third row as a third column, 1 minus 1 0 1 minus 1 0. Okay, my dear children. Understood this step, my dear children? Right. Now by taking minus from all the elements, we are taking minus common. Then we get these elements 0, 1, 1. From the first row, for second row and third row, we are taking minus common. So we get second row minus 1, 0, minus 1. Third row 1, minus 1, 0. Okay, my dear children, this is nothing but matrix A. So minus A. Here we got A dash is equal to minus A. Here A dash is equal to minus A. Hence proved. The given statement is proved. Understood, my dear children? Right. Now come to the question number 8. For the matrix A is equal to 1, 5, 6, 7. Verify that first part of the question is A plus A dash is a symmetric matrix, and second part of the question is A minus A dash is a skew symmetric matrix. Understood the question, my dear children? Right. Now let us write the given data. What is given here? Matrix A. A is equal to matrix 1, 5, 6, 7. Then A transpose. Do you know how to find A transpose? Just by interchanging the rows and columns. We write first row as first column, second row as a second column. So 1, 5, 6, 7. Understood this step, my dear children? Right. Now let C is equal to A plus A dash. We assume that here C is equal to A plus A dash. We are finding the sum of the matrices A and A dash. So I wrote here A, matrix A plus here matrix A dash. Now we are adding these two matrices. Understood this step, my dear children? Right. This is equal to, adding the two matrices means we have to add the corresponding elements in the two matrices. So 1 plus 1, 5 plus 6, 6 plus 5, 7 plus 7. Understood this step, my dear children? Right. That is equal to 1 plus 1, 2, 5 plus 6, 11, 6 plus 5, 11, 7 plus 7, 14. Understood this step, my dear children? Right. Now let us find here its transpose. C dash is equal to 2, 11. We wrote this one as first column. Second row 11, 14. We write this second row as a second column. Understood this step, my dear children? Here, if you observe, C is equal to C dash. These two matrices are equal. Hence, therefore, C is equal to A plus A dash is a symmetric matrix. Do you remember the definition of symmetric matrix? If A transpose is equal to A, then matrix A is said to be symmetric matrix. Right. Now let us assume D is equal to A minus A dash. We are assuming like this. D is a matrix. A is equal to A minus A dash. Okay, my dear children. Right. That is equal to, we are substituting here A matrix minus here A transpose. Okay, my dear children. Now we are subtracting this matrix from this matrix. So 1 minus 1, 5 minus 6, 6 minus 5, 7 minus 7. By subtracting the corresponding elements, then we get this matrix. Understood this step, my dear children? Right. This is equal to 1 minus 1, 0. 5 minus 6, minus 1. 6 minus 1, 6 minus 5, 1. 7 minus 7, 0. Now we got here matrix D. Now we find D transpose or D dash, means it's a transpose. So first row is written as a first column, second row is written as a second column. Now we are taking minus common from all the elements of this matrix. Minus of 0, here minus 1, here 1, here 0. This is nothing but matrix D, that is equal to minus D. So finally we got here D dash is equal to minus D. By the definition of skew symmetric matrix, here D is a skew symmetric matrix. D is nothing but A minus A dash is a skew symmetric matrix. Understood, my dear children? Right. Now come to the question number 10. See here the first part of this question. Express the matrix 3, 5, 1, minus 1 as the sum of a symmetric and a skew symmetric matrix. Understood the question, my dear children? We have to write the given matrix as the sum of a symmetric and a skew symmetric matrix. So let A is equal to 3, 5, 1, minus 5. Okay, my dear children? Right. Now let us assume that P is equal to 1 by 2 of A plus A dash. We are assuming like this. P is a matrix that is equal to 1 by 2 of A plus A dash. Now we are finding this matrix P. The 1 by 2 into, we are substituting A and A dash. Here this is A and this is A dash. Understood this step, my dear children? Right. Now come to the next step, that is equal to 1 by 2 by adding the two matrices. Means by adding the corresponding elements in the two matrices, we get 3 plus 3, 5 plus 1, 1 plus 5, minus 1 plus minus 1. Understood the step, my dear children? Right. That is equal to 1 by 2 of 3 plus 3, 6, 5 plus 1, 6, 1 plus 5, 6, minus 1, minus 2. Understood this step, my dear children? Right. Now we multiply every element of this matrix by 1 by 2. This is a scalar. Multiplication of a matrix by a scalar. Okay, my dear children, that is equal to 1 by 2 into 6, 1 by 2 into 6, 1 by 2 into 6, 1 by 2 into minus 2. Understood this step, my dear children? Right. That is equal to, by simplifying these two numbers, we get here 3. By simplifying these two numbers, we get here 3. By simplifying these two numbers, we get here 3. By simplifying these two numbers, we get minus 1. Understood this step, my dear children? Right. Now P dash is equal to matrix 3, 3, 3, minus 1. If you observe, P and P dash are equal. Thus, P is equal to 1 by 2 of A plus A dash is a symmetric matrix. By the definition of symmetric matrix, we can say that P is a symmetric matrix. Also, let us consider Q is equal to 1 by 2 of A minus A dash. We are assuming that Q is a matrix such that 1 by 2 of A minus A dash. We find here Q matrix. So 1 by 2 into, we wrote here matrix A minus here A dash. Understood this step, my dear children? Right. That is equal to 1 by 2 of, we are subtracting this matrix from this matrix. So 3 minus 3, 5 minus 1, 1 minus 5, minus 1, minus of minus 1, we get here plus 1. Understood this step, my dear children? Right. That is equal to 1 by 2 of 3 minus 3, 0, 5 minus 1, 4, 1 minus 5, minus 4, minus 1 plus 1, 0. Understood this step, my dear children? Right. Now we multiply this matrix by this scalar. Multiplication of a matrix by a scalar. Understood? Now 1 by 2 into 0, 1 by 2 into 4, 1 by 2 into minus 4, 1 by 2 into 0. We multiplied each and every element of this matrix by this scalar 1 by 2. Understood this step, my dear children? That is equal to, by simplifying these two numbers, we get 0. By simplifying these two numbers, we get here 2. By simplifying these two numbers, we get minus 2. And by simplifying these two numbers, we get 0. Understood this step, my dear children? Right. Then Q dash is equal to, we are finding here transpose of matrix Q. Okay, my dear children? Right. That is equal to 0 minus 2 to 0. That is equal to minus of, we are taking minus common from every element of this matrix. So minus of 0 to minus 2, 0. Understood this step, my dear children? That is equal to minus, this is nothing but matrix Q. If we observe Q dash and Q minus Q, they are equal. So here Q dash and minus Q. Therefore, Q is a skew symmetric matrix. Do you remember the definition of a skew symmetric matrix? If A dash is equal to minus A, that matrix is said to be a skew symmetric matrix. Right. Now, P plus Q, we are adding the matrix P and Q. We got P matrix 3, 3, 3, minus 1 plus Q matrix is 0, 2, minus 2, 0. Now we are adding these two matrices. Means we have to add the corresponding elements of these two matrices. So 3 plus 0, 3 plus 2, 3 plus minus 2 means minus 2, minus 1 plus 0. Understood this step, my dear children? Right. That is equal to 3 plus 3, 0, 3, 3 plus 2, 5, 3 minus 2, 1, minus 1 plus 0, minus 1. If you observe this matrix, it is nothing but the given matrix A. Thus, A is represented as the sum of a symmetric and a skew symmetric matrix. Okay, my dear children? Right.